Okay, this is section 4.1, quadratic functions and transformations. Going to be learning about a new equation to graph this time. So our objective here is to graph and identify the quadratic functions in vertex form. Okay, so first thing we want to talk about here is what does a quadratic equation look like? Okay, a parabola is the graph of a quadratic function. A quadratic function can be written in the form f of x, or in this case we would put a y here, and it would be ax squared plus bx plus c. And you'll notice this is a quadratic equation. It's a squared term, okay, where a cannot be 0. Okay, so we're going to be able to graph any quadratic function that's a transformation of the graph of the parent function y equals x squared. And we're going to talk about this actual equation here in just a little bit. Okay, other key parts. The parent function, the parent quadratic function. The parent quadratic function is y equals x squared. Okay, its graph is a parabola. A parabola is the U-shaped graph. So the parabola is the shape of the graph that looks like this. Okay, now we're going to talk about a lot of different things about this. Okay, the axis of symmetry in this case is x equals 0, and the vertex is at the ordered pair 0, 0. So you'll notice here, as you look and see, they have this graphed. Okay, you'll notice again the vertex, the very tip of it is at 0, 0. The axis of symmetry is x equals 0, this red line right here. The right half and the left half are exactly the same. And you'll notice that it's not, our absolute value graph was in straight lines. This is not straight lines, this is curves. Okay, so that's what the parent function looks like of the quadratic equation. Okay, so the parent function. Now, the parts that you're going to be looking at here now are these. The vertex form of a quadratic function is f of x or y equals a times the quantity x minus h squared plus k, where a cannot be 0. Okay, and we're going to talk about these things here as well. The axis of symmetry is the line x equals h. That's no different than it was when we had a absolute value graph, or if we were to have it on the square root function. Okay, the vertex is at the ordered pair h and k, or the opposite of h and k, because remember again, h is negative in the equation. Okay, that's where the tip of your graph is going to be, at the vertex. Okay, so now let's take a look here now at this general form. Y equals a times the quantity x minus h quantity squared plus k. And let's talk about the different movements of this graph here. Okay, we're going to start with this guy right here, k, no different than before. Okay, this guy here is going to move us up or down. Okay, h is going to move us left or right. Again, remember, it's always the opposite. So if it's negative, it's going to be right. If it's positive, it's going to be left. And A tells us whether we have a stretch or a compression. Or we can have and it's also going to tell us whether we reflect it or not, whether we flip it as well. Okay, the vertex is at the ordered pair 0, 0. Or sorry, not 0, 0. We'll go back on this. The vertex is at the ordered pair h and k. We're not talking about a specific problem. H and k. The axis of symmetry is at the line x equals whatever the value of h is. Okay. And again, you saw the name earlier before. It starts with a P. We call this a parabola. That's the name of the type of graph it is. Called a parabola, that curve shape. Okay. All right, now how are we going to go through and graph these? So when a is 1 in this equation, okay, if you look at this equation here, when a is 1, so in other words, you're probably not going to see a number there. What you're going to do is you're just going to plot the points of the parent function, and you'll see that in an example that I look at. And then you're going to shift your points accordingly. So you might shift them right 2 and up 3. You plot the points of the parent function, and then you just shift your points, and then you draw your curve. So when a is equal to 1, it's fairly easy, not too horribly complicated. When a is not 1, we're going to do it a little bit differently. Okay? When a is not 1, you're going to plot the vertex. Okay? So when you plot the vertex, then you're going to pick the first 2 x values to the right of the vertex. Okay? And you're going to put them in a t-chart. Then you're going to substitute them into the equation and find the values for y of those 2 points. Okay? And then you're going to plot those 2 points on the graph. All right? Once you've done that, okay, you'll have 3 points there. To find the other 2 points, you're going to reflect them across the axis of symmetry. You'll have 5 points, and then you can draw your curve. Okay? So, this is the explanation of how we're going to graph a quadratic function. Okay? Don't forget about part 2. I go through the examples of how to actually graph it.